Oloruntoba Shegun is my name. In the previous class, we have considered isomerism of butane. In this class, you are going to learn isomerism of pentane. Pentane, as the name implies, has 5 carbons. And you know that because of the ending name ANE, pentane belongs to the family of alkane. And that is why we have the ending name end with ANE. So let's take this structure you are seeing on the screen. This structure you are seeing on the screen simply means that we have 5 carbons surrounded with 12 hydrogen. This is the first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. Now, when we now say isomer of pentane, we are simply saying what are the other possible way by which we can draw pentane. What are the possible way by which we can draw pentane? Now, look at this structure right now. This pentane, this is called normal pentane. Now, let's check another way of drawing. Let's check another way of drawing pentane now. The structure you are seeing right here is isopentane, which means that another way of drawing pentane is the structure you are seeing on the screen. Check it very well. Look at this now. How many carbon is our longest carbon? That is where to start from. Before we give this one name, I did not put the name there because I want us to do it together. What is our longest carbon? So let's quickly check this to determine our longest carbon, which means that the one that has the highest number of carbon, regardless of how we are counting. Let's start counting from right. If you count from right, you can say 1, 2, 3. These are number 3 carbon, and this is 4. So counting from left to right, we have 4 carbons as a straight carbon. If you count from right to left, we still have 4 carbons as a straight carbon. Now, if we count from this right up, how many carbon is that? That is 3 carbon. Now, which one is our longest, 3 or 4? You agree with me that our longest carbon here is 4 carbons. That is the total number of carbon that is so much in the structure. It is 4. And when we call 4 carbons, what is the name given to 4 carbons? You agree with me that it is butane. So the parent name for this compound now is what? Is butane. That is the first thing you need to write. So this attachment that is up right here is our alkyl group. And we are going to give it name too. So this is CH3 forming an alkyl group. And it falls on which carbon? Now let's consider this. According to the rules, if you start counting from your right, this alkyl group is on number 2 if you start counting from right. Now let's start counting from left. If you start counting from left, this is here 1, 2, 3. So this alkyl group falls on carbon number 3. And remember the rules of naming, that this alkyl group, you must give the number you are going to ascribe to this alkyl group must be the lowest number, regardless of how you are counting. So if you are counting from the left now, our alkyl group will be on number 3. If you are counting from right, our alkyl group will be on number 2. So from our right, our alkyl group is on number 3. From our left, our alkyl group is on number 2. Because of that, the name you are going to pick is the one that you are counting from number 2. So our alkyl group is on carbon number 2. And that is why the correct name for this structure will be 2-methyl-butane. Remember that the longest carbon is 4. The correct name for this structure is what? 2-methyl-butane. And if you count the total number of carbon, you will see that it is 5. The correct name for this compound is 2-methyl-butane. I have explained that the longest carbon here is 4, and then the methyl falls on carbon number 2. The methyl falls on carbon number 2, and then the methyl group is just only single carbon, and that is why we call it 2-methyl-butane. And this compound in all is an isomer of pentane, because when we count the total number of carbons in this structure, the total number of carbons will be 5, which means that we derive this compound from pentane. This is isomer number 1 from pentane. Let's check another isomer from pentane. This is another isomer of pentane. Pentane is 5 carbons. So if you check the total number of carbons in this structure, you will see that it is 5. This is 1, 3, this is 3 carbon, and then this is 2 carbon. Say 1 carbon here, 1 carbon here, and then another one by the other side, adding to that 3 carbon, making 5 in all. So this is another way of drawing pentane, which means this structure is an isomer of pentane. I have shown you 2-methylbutane that is also an isomer of pentane, which means that we derive 2-methylbutane from pentane. We also derive this one too, 2,2-dimethylpropane. So how do we arrive at 2,2-dimethylpropane? The rule is still the same. How did we arrive at 2,2-dimethylpropane? Remember, the rule is still the same. You are going to consider the longest carbon. So if you are counting from left to right, you will see that this is 3 carbons like this, starting from this place, 1, 2, 3. And if you are counting either from up to bottom, it is still 3 carbon. Irrespective of how you are counting, the longest count you are going to get is 3, and that 3 carbon is propane. Regardless of how you choose to count, the longest carbon in this structure will be propane, because that's the highest number of carbon there. I mean, when you are counting either straight or bend. Okay, after you have counted, let's say we pick the straight one for easy counting. You will see that there's an attachment up, which is this. There's also an attachment down, which is this one. Please take note, whenever CH3 is just at the edge of any carbon, it's no more an attachment. You will count it as a family. You will see that all these ones too are CH3, but you don't regard them as attachment because they are at the edge. If any carbon is at the edge, you don't call it attachment. You call it as a part of the parent carbon. We are still going to do more on that. One carbon is up as an attachment, another carbon is down as an attachment. But if you count very well, whether you are counting from right or you are counting from left, both of them, they are on carbon number 2. If you are counting from the left here, this attachment up is on carbon number 2. This one down is also on carbon number 2. And that is why we have 2 for the first one and then 2 for the second one. And both of them are methyl. And because we're having 2 now, that is di. 2,2-dimethylpropane, which is also an isomer of pentane. This is where we are going to stop isomerism for today. In the next class, we are still going to consider isomers of some other molecular structure. Thank you. See you in the next class.